Every model until now learned from labeled data, examples with the answer attached, but often you have a big pile of data and no labels at all. Can a machine still find the hidden groups? Yes. This is unsupervised learning. Here is our data, just gray dots, no colors, no labels. But your eye already spots it, does it not? There seem to be 3 natural clumps. K-means is the method that finds them automatically. First, we tell it how many groups to look for, let's say 3. So we drop 3 center markers onto the map at random. Right now they are in a clumsy spot, off to one side. That is fine. They will fix themselves. Now the loop begins, and it has just 2 steps. Step 1, assign. Every dot looks at the 3 centers and joins the closest one, taking on its color. Step 2, update. Each center slides over to sit at the average position of all its own colored dots, its center of gravity. Watch them jump toward their groups. Then we just repeat. Assign every dot to the nearest center again. Move every center to its new average. Again. And very quickly, the centers stop moving. They have settled right into the heart of each clump. The colors lock in. With no labels at all, K-means has discovered the 3 groups on its own. But wait, we told it 3. What if we did not know the number? For that there is a neat trick called the elbow method. We try many values of K and measure the total spread, how tightly the dots hug their centers. More groups always means tighter spread, so the line keeps dropping. But look for the sharp bend, the elbow. Here it is at 3. After that, adding groups barely helps. That bend is your natural number of clusters. And that is the whole idea in one line. Each center is simply the average of the points that belong to it. Assign, average, repeat. Beautifully simple. So K-means turns a shapeless cloud of data into clean groups, with no labels needed. Just remember, you choose how many groups, and it works best when the clumps are round and roughly even. Clustering struggles when each point has hundreds of features, too many to even picture. So next, we learn how to squeeze all those dimensions down to just a few while keeping what matters. Dimensionality reduction.